This lab report is about an experiment on the topic constant velocity. I recorded a video of an object rolling on the ground, and I have cropped out a part of the video where no horizontal forces were exerted on the object. Then I used Tracker to extract the object's position and corresponding time because Trackers is extremely helpful while analyzing motions of objects. So for this lab, I also constructed a computational model that describes my observations based on Newton's second law. The purpose of this lab is to observe the motion of this object moving while no force in its directions of motion is exerted. So the only forces are the gravity and the normal force. Since the object is not under the influence of any force in its direction of motion, after the initial speed was given, the object would move at a constant speed in the initial direction. Newton's first law that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force also agrees with this fact. As you can see, this is a screenshot of my tracker. So this is the position and time graph, which shows us basically a decreasing straight line, meaning that the object is moving at almost a constant speed. There are some faults concerning the motion in y-axis because I just could not click on the exact same height every time. We're just going to ignore that. Okay, and the ball's initial position is 0.0019 meters. Ignore the forces, and the ball's initial speed was negative 0.33 meters per second. And here's my code on Go script. I set the ball's initial position accordingly as well as the initial speed. And if no extra force was given, the ball's velocity wouldn't change and the ball's position would be the current position adding the ball's velocity multiples delta t, which is 0.033 seconds. And this is the ideal position time graph, which is a perfect decreasing straight line since I set the movement of the object in negative x-axis direction. So for the what if question, I do not think the results would have changed if I chose another direction for positive x-axis, because whichever the direction is, it is the difference of positions at different times that matters. My observations can be predicted well by my computational model when I set the net force equal to 0, and I believe in this observation only two forces were given after the initial push, the gravity and the normal force, and neither of them will have an impact on the motion of the object. Thank you.